Let us do this problem. Okay. So on this one again, to find out the critical number, what we do, we find out the first derivative, f prime equals to 2 minus 3 times 2/3 times t to the 2/3 minus 1. You understand the derivative, right? If you simplify that, what do you get? 2 minus 2t to the negative 1/3, right? If you simplify this, you will get 2 minus 2 over t to the positive 1/3. 1/3, right? So there is 1 in the denominator. I want to combine that, right? So what do I get? This is equals to 2t to the 1/3 minus 2 divided by t to the 1/3. You see that? So for the critical values, we need to do either f must be. So either f prime must be 0 or f prime must be undefined, right? This is needed for the critical value, right? So as the previous example, so if you do f prime equals to 0, then you do the numerator equals to 0, right? So you get 2t to the 1/3 minus 2 equals to 0, because you can multiply that to the 0, right? So this implies, let me add 2 on both sides. You get 2t to the 1/3 equals to 2, right? Divide by 2. What do you get? You get t to the 1/3 equals to 1. So basically t is 1 critical number. And what is the another critical number? Another critical number is t equals to what value of t makes this undefined? 0, right? Makes f prime undefined. So what is the critical number? Therefore the critical numbers are x equals to, sorry, t equals to, so the critical numbers are t equals to 1 and then t equals to 0. These are the critical numbers. Let us look this example, okay? Find the critical numbers again. For the critical numbers, you find out the first derivative. So f prime is how much? 2 cosine of x minus, it is like cosine u, right? What is the derivative of cosine u? Negative sine u times the u prime, right? So if you simplify this, you will get 2 cosine of x plus 4 sine 2x. That's what you get, right? So to find out the critical numbers, you should set that equals to 0 and then see if at which points for what value of x you get the first derivative 0, right? So f prime equals to 0 implies 2 cosine of x plus 4. Do you know the value of sine 2x? It is 2 sine x times cosine of x equals to 0. So can you take out something? 2 cosine of x, take out, right? So what do you get? You will get 1 plus, you get, by the way, this is 2, right? So if you take 2 cosine x out, then you will get 2 sine x equals to 0, right? So you do either 2 cosine of x equals to 0. So what values of cosine will give you 0? So it is cosine of x equals to 0, right? If you divide both sides by 2, that's what you get. So what values of x will give you for the cosine 0? That is pi over 2, right? And then 3 pi over 2. That's what you will get. You see that? Pi over 2 and then 3 pi over 2. Similarly, you want to find out for this the other factor equals to 1 plus 2 sine x equals to 0. So subtract 1, you get 2 sine x equals to negative 1 and divide by 2. Divide by 2, right? So sine x equals to negative 1/2. So sine is negative in third quadrant and then fourth quadrant, right? For the third quadrant, you should do, because sine 30 degree is 1/2, right? Positive 1/2. So sine pi over 6 is positive 1/2. So to find out the value in the third quadrant, you do pi plus pi over 6. That will be 7 pi over 6 is one value. That is 210 degree. Okay, and then you do 2 pi minus pi over 6. You will get 11 pi over 6. That is for the fourth quadrant. Okay, so the critical values here are x equals to pi over 2, 3 pi over 2, and then 7 pi over 6, and then 11 pi over 6. So these are the critical numbers there. Okay, let us briefly talk about the extreme value theorem. What it says is, if a function f(x) is continuous on a closed interval ab, then f has both minimum and maximum on that interval ab. Meaning, if a function does not have any break, and then if in an interval that contains the boundary, that is the closed interval, then it has both maximum and minimum lies on that interval, right? For example, in this case, you see that the function f(x) has global max. What is the highest point? At b, right? At x equals to b, and global mean at x equals to c. See, this is the lowest point, right? But if the function is not continuous, or if the function is continuous in an open interval, then you cannot guarantee the maximum and minimum global max and global mean lie in that interval. For example, in this figure, the function is continuous in the open interval AB, right? Here you have a parenthesis. So what is the global mean? Global mean exists at x equals to c, because at x equals c, it has the lowest point. But the global max does not exist here, right? Because it looks like at B, the height is the highest one, right? But B does not fall in that interval, so we cannot say at what point it is peaking the highest point. So we say it does not exist. So the global maximum does not exist for this figure. The reason is because it is continuous in open interval. So sometimes if a function is continuous in an open interval, for example, let us look at this one. So if you have this one, let's look at that, and then so suppose this is A and this is B. Okay, then in this case the function is continuous in the open interval AB, right? But it has both global max and global mean, because see, at C it has a global mean, and at D it has a global max. So what can we tell about this then? If a function is continuous in the closed interval, then that guarantees both maximum and minimum lies in that interval or on the boundary. But if the function is continuous in open interval, or if the function is not continuous, then we cannot guarantee the global max and global mean lies in that interval or on the boundary. Okay, so this is what it is saying. So but if the function is continuous in the closed interval, we are 100% sure that the global max or global mean lies somewhere in that interval or on the boundary. That's what it says. Okay guys.